So we've already talked a little bit about, and Sam and Esteban both talked about this concepts of smart manufacturing as well. I had an opportunity to present this solution earlier in the year at the Sustainable Manufacturing Expo, which was held out in Anaheim back in February, I guess. And really the gist was that we have these convergences which are very opportunistic for all of us in this industry, because we have all these tremendous technologies coming to the forefront, that we have a cornucopia of technologies we can take advantage of. And at the same time, we have tremendous pressures in order to leverage these technologies in order to drive sustainability, better use of resources, driving towards greater efficiencies in all aspects of manufacturing operations. These two are not disconnected. They are quite symbiotic, I would maintain. And we can think about our opportunities and work that we do in smart manufacturing as being a footprint for enabling, or a foundation for enabling smart sustainability. Think of some of the use cases. You have advanced connectivity. I think it was Esteban who just mentioned the fact that he had a scenario in his project where people were going around to various sites and remote locations and transcribing data and then emailing that data. Well, what if you can use an ignition architecture combined with a low latency, low bandwidth technology that can handle some of these difficult network connections like MQTT, in order to collect a greater amount of data, more resolute data from these remote sites. I mean, that's what we've done essentially in the project I'm going to show you in a second. AI is, of course, something that's on the tip of everyone's tongue right now, all sorts of different types of AI, but applying AI and machine learning technologies can really help you understand historically how you've used resources and the interplay between the resources that you use, let's say the materials you use, the quality aspects of your product, the labor that goes into your product, all sorts of different vectors or life cycles that influence the operations in manufacturing, and how they come together and converge, and how you can optimize those using machine learning algorithms in order to optimize your sustainable footprint. This is the application of AI that I find most interesting in sustainability. And of course, cloud and edge computing, because now we can actually lease our compute power, right? We can expand our compute power and reduce our compute power. And compute power, as we know, because again, part of the AI topic is all about data centers and how voracious some AI tools are in using resources. Well, again, coming on the heels of that, we're going to be a lot more agentic, which is the term that a lot of the AI guys want to use. But think also containerization, modularization, some of the things that Sam showed with the Kanoa type solution, and Ignition as well, as they go to a more containerized and cloud-based platform, which Esteban also talked about. You're going to see a lot more distributed solutions that are much more efficient in how they are implemented and the energy that they use. Let me talk a little bit about the solution that Inflection Point implemented for one of our customers. I find a solution interesting because, of course, it's right in the wheelhouse of sustainability. It's the technology and the industry is called renewable natural gas. The idea is that you can generate natural gas from resources or what would be considered normally waste product. In this case, we are implementing mini manufacturing facilities at dairy farms across North America. So we are, you can imagine a dairy farm, lots of cows, obviously, lots of infrastructure to handle the capture of milk from these cows and keeping the cows healthy, etc. And then the cows have a byproduct, they have waste, essentially, cow manure. And those slurries of cow manure have to be dealt with. Sometimes you can turn them into some fertilizer. There's certainly some use cases for using cow manure, but a lot of it is just waste product. Well, we have now a way to take that cow manure as an input product, raw material, if you will, into these mini manufacturing sites through a digestion process, a gas upgrading process, and turn that into green natural gas that can be put back into pipelines and then sold to customers and sold to either individuals that subscribe to receive this, or actually into the general pipeline for you and I to use as heating and cooking natural gas. I think it's a smart manufacturing solution because it involves a couple different things that are unique. We're building these mini manufacturing sites in these remote locations. So just like Esteban pointed out in his challenge, you have remote locations that aren't necessarily sustaining manufacturing facilities. They are not staffed, and yet they require a great deal of control and automation and safety. right? I mean, you're dealing with flammable materials, et cetera, explosion situations. So safety is paramount, security is paramount, cybersecurity is paramount. You're implementing automation, you're connecting these sites together through leased line internet and or 5G and LTE technologies. You do require 24/7 operation teams to watch these sites remotely, to activate these sites and control these sites remotely. Another thing that's kind of interesting is because this is a new manufacturing arena, the companies that are implementing renewable natural gas get opportunities to do things that other companies might not, like choose their ERP for the first time, choose their CMMS for the first time, which allows us to have a conversation about things like unified namespace and how a tool like Ignition can help you structure your data so that it marries and integrates seamlessly with that CMMS. So if I want to track my assets, as I do as any manufacturing facility, those assets are run in operation. The data I collect from Ignition, how long I ran a particular flare, how much I used a particular pump is directly marriable to the CMMS system, and I can generate condition-based maintenance use cases now. So I'm really driving smart manufacturing through the blending of a data-centric paradigm. And then finally, think about the fact that, what is the financial viability for a solution like this? I'm putting mini manufacturing facilities in dairy farms. This has got to be awfully expensive. I've got to be able to do this in a repeatable fashion. There are 50 sites that we've stood up through North America. I've got to be able to do this cost effectively. It's got to be maintainable. And there has to be a way to make this gas essentially a sellable product. We do that through a concept of carb credits, which drive the sustainability use case. So what is a carb credit essentially? It's a state-run program essentially through California at this point, but different states and different regions, like here in the Northeast where I am, the United States, we have a regional consortium of different states that basically offer, governments and or business can offer basically a carbon offset or a credit that comes from various forms of carbon taxes. These can be done through various mechanisms, like I said, ETSs, carbon credit mechanisms, internal carbon pricing within organizations. So even within your own organization, you might use this to drive some sustainability use cases. In this case, we're taking advantage of government-run programs for this. How do you apply for a carbon credit? Well, you do this by demonstrating that you can turn this raw material, this, what we've considered a waste product, like a cow manure, into a sellable renewable natural gas. But to do that, you have to run a digester, you have to run a gas upgrader, you have to expend energy in order to create something that will be used as energy. And so there has to be a very simple thermodynamics, energy balance equations, right? In order to demonstrate that we are generating something that's more valuable than the energy that we're putting in. And to do that, we need a tremendous amount of accurate data collection. We can't just sign off on something and say that we've created this amount of gas and this amount of gas took this much input manure and this is terrific. We've done our product, now give us our tax credit. To file for these types of credits, there's an ongoing labor of continuous accounting, and that accounting drives right down into the heart of the manufacturing operation, good data collection, metering across the entire process, and understanding those various energy balance equations and being able to support them with good data. So that data from remote locations, getting that to a central location, and then being able to process that and generate the proof that we deserve and have earned those carb credits is key to sustaining this manufacturing. What does this look like from an Ignition perspective? We're in an Ignition webinar. We're standing up these mini manufacturing facilities. And so each of these sites has anywhere between 10,000 and 30,000 tags. They're a collection of best of breed OEM equipment combined with balance of plant integration, and then an Ignition system that sits on top of that at every site that has redundancy, local data collection, provides visualization, alarming, all the things that Ignition does very well, including important data collection using the Ignition Historian for that accurate carb credit reporting. And then we bring that data together and we use that like with partners from Cirrus in order to implement MQTT, bolting into Ignition and using these modules directly in Ignition in order to generate robust data collection from each site with store and forward capability. So if we lose connection through that 5G connection, we're going to keep that data locally. We're going to eventually restore that connection, push that up to what we call our multi-site location, which is an enterprise level multi-tiered gateway SCADA system built on Ignition that allows us to see across multiple sites, drill in, build dashboards with the dashboarding tool in perspective to give ourselves a bird's eye view of what's happening at each site, drill down, actually see the details, the alarms, all the information necessary to remote in and control that site. In addition, we have many different stakeholders that use this type of tool at the enterprise level, such as our dispatch crews, which have to understand, okay, when we're making a new batch of natural gas and that's ready to be hauled off with trucks or put into a pipeline, there is a transfer of custody, there is a distribution network that comes into play, and those people need to understand that data, dispatch trucks to the location, know where those trucks are en route, bring that gas into a drop-off point or an interconnect where it's then brought into the pipeline. And again, that chain of custody involves a lot of data collection all at the ignition level, because it is also part of what gas do we actually deliver to our end customer to ensure that we can apply for that CARB credit. So I like to say, from a smart manufacturing perspective, when you think about sustainability and you think about smart manufacturing, I think it's a lot about life cycles that cross different life cycles that we know very well in operations and how they interact. You know, we have a production life cycle, but we also have our management of our assets, which kind of falls into that maintenance realm, right? We have our product life cycle, the product that we're making, the quality to which we need to make that product. We have a supply chain life cycle where we need to understand what our raw material inputs are. That even affects and again crosses over with the asset life cycle to make sure we have spare parts on hand and those spare parts are available in the right quantities to remote locations in order to keep facilities up and running. We have our trained workforce, and that workforce now has a lot of demands on it because it needs to be process experts. It needs to also understand how they can manage a system remotely and understand the system and the process health and the safety of that system and that process while they're remote from the site. So they have to have the right level of information, which involves the integration of a lot of this data from Ignition, also with camera technologies and other technologies and security technologies at the site that they integrate together through that Ignition portal. And of course, we have order to cash, which in this case is cow to cash. Lots of technologies come into play. Like I said, the accuracy of emission monitoring. If I'm flaring off a gas, because I'm not able to use that gas or I'm not able to upgrade that gas, that's a loss, and I need to deduct that from what I'm ultimately going to present as a CARB credit and what I've produced. Real-time SCADA visibility, accurate historical data, and material energy balances. As I mentioned, MQTT being an important technology here to dealing with the kinds of network connections we have, and the visual recognition of AI and accuracy. We track our trucks using visual AI, knowing what trucks pulled up to a particular loading station, what gas was offloaded onto them when they came to an internet and connect and loaded that gas back into a pipeline or an interconnect site. We also track that truck there as well. And then finally, I'll leave you with just a couple of quick thoughts about smart manufacturing and sustainability. And as I said, I'm a big fan of the idea that there's a convergence between these two technology things that are happening in real time. Both, we're all part of it. You really can't. Sometimes it's in the world of sustainability, it gets a bad rap. ESG was a big acronym for a while on how organizations were going to report on projects and how they were going to make their organizations more sustainable and responsible to shareholders, essentially. I think at the end of the day, if you want to think about sustainability projects, it's no different than selling a production efficiency project. Sam mentioned OEE before. OEE is ubiquitous within manufacturing and it drives production capability, right? If you're thinking about OEE, you can't really use OEE unless you drive ROI. What is this OEE number telling me and how can I improve it and how does it affect the bottom line? It's no different with sustainability projects. So when you think about sustainability, consider what the manufacturing goals are. Do you want to be more resilient? Do you want to implement digital technologies and how can they help with sustainability? The labor issue here, right? Our workforce upskilling, our workforce, labor shortages in manufacturing, et cetera. How can they improve with sustainability and smart manufacturing? And think about the use cases here. Of course, we talked about waste reduction and wages efficiency, looking at our utilization of utilities as resources, essentially, driving to best quality, driving to predictive maintenance or condition-based maintenance. These are all use cases that are both smart manufacturing use cases and sustainability use cases.